Hello, this is Brian McHenry of McHenry Software. This is a quick intro to our msmac3D release. We're going to go through some of the graphics items, give you a general overview for those of you who are new to msmac3D, but also some additional features that we've added, which will be of interest. What we're watching right now is the my first project, and what I've done is use the tracking camera to create this rather dramatic view of the one car rolling and coming to rest. I want to go through a few of the new features. So let's begin. First item, of course, this is the graphics portion of msmac3D. It has a number of buttons and functions. There's been some videos that cover them, but I'll do a very quick overview of some of the features. Up on the top, we have a number of buttons here. Main ones of interest, at least for this is the tracking view, where I used a way to add and vary the camera. If you click on your right mouse button, it brings up the camera control, which allows you to tilt the camera, pan the camera, zoom the camera. And with the tracking view, you can save those at different frames and then see how it looks, and you run through it a couple times and do that. Then also you can have fixed view. So let's turn off the tracking for now. And you notice you have here's a fixed view, and let's just say I decided I wanted to keep this. I just set that view by selecting item 2. Now I can go to a different view and come back to that view. There's some other views that are in there. There's basically to give you a number of views to use for your evaluation of how you match evidence. Basically, with msmac3D, you want to bring in your terrain information, any bitmaps you have, any diagrams, DXF files, so that you put your evidence, so that you're running your reconstruction on the actual evidence. Now, if we go back to the tracking view again, we hit pause, we go tracking view, you'll see we go back to the view that we started this out with. Also on the bottom here, you can recalculate the simulation. You can do a 2D simulation to see how that looks compared to the 3D. Initial positioning, we're looking in the lower left corner here. There's also the ability to go backwards and forwards. There's a slider bar here that moves you forwards and backwards. You can play and stop. Just hitting the play again makes it stop. Up in the upper center kind of here is a help movie clips. This we're going to be adding to, and it'll have a number of new additions. Probably by the time you see this, when you actually start up your msmac3D, you'll see there'll be a bunch more, and we can change it daily. You ask a question, we may create one, and when you click on one of them, it brings up the video. And one of the things we've changed through your recommendations is that we have now that it runs asynchronously, meaning you can run it in parallel. So you could watch during instructional videos, you can watch it and then do the things on the actual program as you're watching it. You can change obviously the sky color, zero plane color, text color. This is in the right corner here. Text color is so that if you have a white background and you need to change it, generally it defaults to white, but now we could change it to black or any other color that you want that shows you a rough overview. We're going to enhance that to be very similar to what's in the msmac2D animation program, to have all as much or as little information you want on it, so that as you're displaying a video or making a movie, it has all that information. Obviously, you can change your screen size, the light for changing what kind of light you have. There's various functions there. Down over here, there's a video called How to Make Movies that talks about this save frames to bitmap option. And one of the more important things we have now, and let me take off the track view so we can watch this a little better, and let's bring up a view that we can see what's going on. Right here we have what's called backup restore. So currently there's a couple in here. Let's go ahead and delete those. And let's just say we're just starting now and we want to save our current run. We're going to call that the start of this demo, so that at any time we can come back to this. Now we go ahead and exit. Now let's just say we want to change. So again, with the initial positions here, you can change the initial positions and speeds. Let's just change the speeds. You notice this one's at 40 and this one's at 40. Let's change this one to 50 just to see what happens. Change that to 50 and we hit, and it shows you that it's running msmac, and it shows you the calculated time lapsed and the so that now you know that it's done, and then you simply click play. See, it's a much different accident when you're at 50 for the one vehicle. Let's go ahead and save that. Let's say, well, we want to save that. We could save that and say 50 miles per hour, vehicle 1, I think that was, but let's go back and find out. We can go and edit that if we want. Let's go ahead and find out. That was, if you click on the vehicle, yes, that was vehicle 1, we changed to 50. Now, if we wanted to go back to our original one, we go here and we say, see, that here's the backup, and here's the restore. We click restore, and it tells you that, hey, the current change that you just made is not saved. Well, we don't really want to save that, so we say, no, it doesn't matter. It runs it, and now you'll watch the tire marks change. We're back to our original. Scenario. Other things that you can change with the initial positioning is we go to the menu here, we go to overhead. You see their positions. If we select vehicle 1, which is this vehicle, notice when you touch a vehicle, it tells you which vehicle it is. And or if you can't see the vehicle, whatever, you can use this to select them, or if it's for some reason they're obscured. And you can move their positions and their orientation. One additional option we have here, again, this is a, let's go back to as a matter of fact, we'll go back to the tracking view since that's a nicer view. This little slider bar here allows you to change the speed at which the playback is. I can speed it up. It runs faster. Or I can slow it down. That's when you're trying to see how maybe the tires match evidence that's on your scene, etc. This allows you to see it in different speeds, etc. And then the normal is right in the middle, which is approximately real time. So now if we go back to the mEdit grid, we'll give you a quick overview of that. This is the main mEdit 3D grid, very similar to the mEdit 32 grid that we formerly had. All the inputs for the program are right in front of you. Over here to the right gives you a description of what each are: the program control, start, end time, integration times, the printout, output time, and stop times. The reason you have stop times is sometimes if you have a long simulation, you want the vehicle to be signaled as stopped, and with digital integration, sometimes it may never get to perfect 0, so you put in a stop other than 0. It's also the positions and orientations, which we demonstrated you can change on graphics. All these other items, we soon will have the ability to change those and edit those from graphics. We'll have dialogues. But you have the dimensions and mass, the A and B, and at any, if you're interested in what's on any of these, if you click on a field and then press your F1 button, it brings up the help file. And the help file includes a description, detailed description of all the fields and what they are. Also, if you notice in the help file, there's a lot of introduction to the programs, and then there's sections called discussion, like on cornering stiffness. There's a whole section on what is cornering stiffness, how do you determine it, what is static margin, how do you calculate static margin, etc. Same for moment of inertia. How do you calculate moments of inertia? What are some references with moments of inertia for further reading? And some sample moment of inertia calculation results. Again, for almost all options, any input card, and again, I guess point one person mentioned was I should mention that card is because the program was created in the 1970s, although we're now, it's all input files. We still call them cards just because it kind of pays homage to the original creation of it back in the 70s by my father, Ray. And the fact that when we first started working on this, when I first started working on it, you use punch cards and you used to have to take them to the computing center and use it. We're living much different times now. Program runs much faster, much better graphics, but we still shows you how simple it is for the inputs. We can get very complicated, and there are, for the 3D components, you can go in, and if you want to change all the suspension parts and everything else, you can do that. But for right now, we're doing everything simple, and all the validations are showing very good correlation with our approximations that are done internally in the program. And they are echoed in the output. But so each of these inputs, there's a steer. Basically all you need when you run a simulation is what are their positions? That's the first card 2 and 3. What are the moments of inertia and specifications? That's card 4 and 5. Tire properties are cards 6 and 7. And then you have braking, which are braking or acceleration are in cards 8 and 9. And then cards 10 and 11 are your steering, pre-impact, post-impact. And then card 12 is for default friction, but you also can do friction zones in the graphics. And then card 13 is your stiffness. What is the approximate stiffness of the vehicle and the inter-vehicle friction, which means when they interact, is it a glancing blow or is it a standard? 0.55 is the standard, but it can change. Then you have the next card, which is really for 3D, is the card 81, which is about what is the height of engagement or the bumper height, which is generally the height of the engagement of cars hitting each other. What's the CG height and what's the overall height? Again, if we hit F1, that brings up our msmac3D manual, and you see talks about bumper, CG, and overall height, and it mentions what those inputs are, what the units are. Up here in the upper right are the buttons for running. You can run the 3D. You can run 2D if you want. All programs run on either. They're forward and backward compatible. You can actually run the original 2D. For those of you that are just 2D users, if you decide you don't want 3D, that's fine. Everything is going to run in 2D just as it did before. But you can also use the 3D graphics, except it'll just show the vehicle on a plane. This also is to run the simulation here. And again, from here, we can also do a backup or restore, file, backup or restore the input file. It brings up that same dialog. So you can do it from here or from the graphics program. We recommend using that because let's say normally SMAC requires iteration, and we do have an automatic iteration that'll be sent out in an upgrade very shortly. Will be an update, I mean. It's included in your msmac3D purchase. And we have it in 2D, but it really doesn't do you much good for 3D because you can have it iterate for 2D and then you run the 3D and it's different because of the fact with weight transfer and everything else. There's a slight difference or sometimes a major difference. The 3D we're working on and should be ready very shortly. It's just we've been spending a lot of time on graphics. And to mention also from this menu, we have the video help also. You have irregular help. Windows, there's tools. AVI Composer we talk about. Charts, that's we're going to do a section on that to show you how to do charts. So if you want to look at the response, like the roll and pitch angle or the accelerations, obviously you should probably run it smaller time increments when you want to really look at these. Speeds, shows you how the speeds vary, etc. And any of the variables that are outputs are all contained and can be plotted. These also are output to a CSV file, which you can open in your Excel spreadsheet if you want to do a more detailed graph. This is not really a high-end graph program, but it does allow you to quickly evaluate how much roll, pitch, or things like that you have. Databases, your vehicle specs, crash test, year model interchange. And then you can manually run it from the run menu, the different items. And then here's where you can look at all your outputs. Your input echo, your run summary is probably one of the most important ones because that includes the impact conditions, separation conditions, end of run, summary of delta V's. There's also a complete output. There's other output files. I'll bring this over here. So for SMAC, for vehicle 1 and vehicle 2, and there'll be for other vehicles if there is. There's also here are your outputs for vehicle 1, vehicle 2, and the SMAC output for the msmac3D output. That concludes our first pass initial introduction to msmac3D release. Please send us any questions you have. Email McHenry at McHenry Software. We appreciate your interest in McHenry Software. Thank you.